1 over any of the previous homework assignments. Didn't get to it yet? That's fine. If you do have questions, you get to it tonight and have questions over it, we can always go over those tomorrow. Now, what we're looking at today is transformations with parent functions. Now, parent functions are the most basic version of the function itself. So we talk about linear functions, y equals f of x equals x. This is the most basic version of this function. There is no transformations done to it. It is the simplest form of the function. Now, same thing with f of x equals the absolute value of x. F of x equals x squared. These are the parent functions.
Good afternoon, Concord High School.
There we go.
If you have not already picked up your JOS.
All right. So these are the most basic versions of each of these functions. Now we can transform them. We can apply transformations to them, move them up, down, left, right, stretch, shrink, reflections, to get the other types of functions we've seen. Because we've seen equations of a line, y equals mx plus b. We've moved it up, down, left, right, stretch. We apply things to it. And being able to understand the difference, or how we go from y equals x, y equals the absolute value of x, or y equals x squared to their new form, helps give us an understanding of what the graph should look like, how it should behave. Now, we're not going to specifically graph each one of these here. I'm not going to give you graph paper. We're not going to get points and do that there. But as long as we have a decent understanding of how the graph should look, how it should change from these parents to its new form, is more important. Because if we know how it's going to move, we get a better understanding of how it works. Now, the types of transformations we have, I'm going to list out because we do have our linear, quadratic, and absolute value. Now, the general form for all these here, y equals a times we have these here. Now, I didn't say it earlier, but these are not the only parent functions we have. Each type of equation has its own. So square roots have a parent function. Y equals the square root of x. Cubics, quartics, quintics, radicals, rational. All of them have their own parent function. Simplest version of it. Now, there is only one other letter that I did not include in these general forms, and it's B, and it normally goes inside the parentheses in front of X. I'm not including it here because we won't really talk about it in this chapter, or in this section 1 and 2. We'll talk about it in 1, 3, and kind of moving forward. But it has specific ones to it. It seems like a lot of information so far, yes? A lot of different letters. We don't know what any of this is, and that's fine, because we have not actually, I've not said what any of this connects to. Each one of these connects to a specific piece. One of them actually connects to 2. You're good? Any questions so far? All right. A transformation changes the size, shape, position, or orientation of a graph. Pretty straightforward. A translation, that's what we're going to talk about first, is a translation. A translation is a horizontal or movement of the graph, but does not change its size, shape, or orientation. Literally, with translations, we're just picking it up and moving it up, down, left, right. That's all it is. Now, the way that we know, especially from an equation, if it's moved, is based off of 2 letters. H is a horizontal translation. It's our left or right movement. And we got to be careful with those. It's opposite of what we think. K tells us if there is a vertical translation. Is it moving up or down? And it's more exactly what we think, what we see. Questions on this so far? So the value that goes in place of H will tell us if we're moving left or right, that amount. K, if there's a value or number in place of K, where K shows up, we're moving it up or down from our parent function. It's telling us how it's moving. So let's actually put some more context to it. So the graph, g of x equals x minus 4. We see where that one is? It's kind of hidden on your note sheet a little bit. So in this class, unless I specifically tell you to graph, especially on the homework, unless I specifically say graph it, do not graph. I'm not looking for graphs. So it says graph this and its parent function, but main thing I want to do with this, what is the parent function of x minus 4? Which one of these three would it be? Linear, absolute, quadratic. Take a guess. Absolute. I would say yes on the second one. This is an absolute because we have absolute values. However, for our x minus 4, we don't have absolute values, so it can't be an absolute value function. Do we have something being squared, a variable being squared? No, so we can't say that it's a quadratic. So what does that leave us with? Linear. Equation of a line. General form, y equals a times x minus h plus k. Linear equation. If I wanted to graph it, I can grab the graphing calculator. We will go over this. I will teach you how to graph and do things like this. Here, equation of a line. Now, as we look at the general form, is there a value in place of h? Do we have parentheses, actually? Do we have parentheses in that equation at all? No, so there is no h. So it's telling me there is no movement to the left or to the right. Do we have a value for k? What took the place of k? Minus 4, yes? Because it's outside the parentheses, it's being added or subtracted. So that's telling me that the function from the parent, we're moving it up or down 4 units. So we can put the 4. Now we need to figure out if we're going up 4 or down 4. Well, what's the sign for k? What's the sign for that 4? It is negative. So normally when we move up or down, up is positive, down is. So it would be down 4 because we're moving down. Down gives us the sign. So k is indeed negative 4. Instead of saying we move 4 units or negative 4 units, we're saying down 4. We're telling it the direction. Sign tells us direction. And we can verify that because if I go down here and say x minus 4, we see that every point on that graph did indeed go down 4 units. Questions on this here? We make up and down, we feel good with it so far? We'll see, we'll do more examples of it in a little bit. G of x equals the absolute value of x plus 1. We said it's absolute value. which means the general form is y equals a absolute value of x minus h plus k. Now this one here, just like the first one, a is 1. We don't have a number written there, so it's understood to be 1. Do we have a value or a number where k is? Is there anything being added or subtracted? No, there's nothing being added or subtracted there, so k technically has a value of 0. We're not going to say that it moves up 0 or down 0, because unless a movement or transformation actually applies something or does something to the graph, we're not going to list it. Okay, it'd be the equivalent of saying, I left my house to come here, and I didn't go to New York. Okay, why? There's no reason for that. Like, if it doesn't tell us anything, it's not saying it's moving, it's not saying it's been stretched, shrink, reflection. We just don't list it. So there is no up or down. But there is a value for h, because we do have something being added inside the absolute value, yes? And that number is 1. Now we need to figure out if we're moving to the left or to the right. It takes a few more keystrokes to get absolute value in here. Oh, we do have the absolute value function, yes? Math, absolute value, we have x plus 1. As we can see here, x plus 1, so we should be moving where? 1 unit to the left or to the right? Right, yes. And as we see the graph, it does indeed move it 1 unit to the left. Yes? That seems opposite of what we think, because it is left 1. But let's look actually at the equation, the general form. Inside the absolute values in the general form, what do we have? We have x minus h. H is the amount that we move to the left or to the right. So just like up and down, if with the last one, minus 4, the value of k was negative 4. It's telling us we're going down 4, yes? As we look at this one here, what's inside our equation is x plus 1. So this here is lining up with what? X minus, because it's lining up with this here, x minus h inside, yes? What's the main way that we can turn a minus into a plus? Is if we have another what? Negative. A negative and negative make a positive, yes? So the only way that we can really change it from x minus h to x plus 1 is really if what? This is actually x minus negative 1. Because that negative and negative would make a positive. So really the value of h is not 1, it's negative 1, which would indeed be moving it to the left, not the right. With that left and right movement, inside those parentheses, inside those absolute values, it's going to be the opposite of what we think. Plus is going to be moving that to the left, minus is going to be moving it to the right. Because x minus 1, h is now positive 1. With left and right, I think the most straight way I've seen it is just opposite of what we think. Left and right is the opposite of what we think. Minus is going to be going to the right, plus is going to be going to the left. Because of that x minus h. It flips that direction. Questions on these here? We will come back to more of them in a bit. We will do more of them later. I want to look at reflection next. Reflection is a transformation that flips a graph over a line called a line of reflection. A reflector point is the same distance from the line of reflection as the original point, but in the opposite direction of the line. It's just flipping it. Now we have a reflection across the x-axis if A is negative. If A is negative, we have a reflection across the x-axis. Now notice that I'm not saying anything about the number of it. If it's negative, if a sign is negative, then it's a reflection across the x-axis. Okay? If A is positive, there is no reflection. We are only looking at the sign for reflection across the x-axis. If that A value is negative, then there's a reflection across that x-axis. Kind of makes sense there. Yes? We will talk about the number here in a little bit. If there's a value there, it's stretch or shrink. Now, it seems like we're adding a ton of stuff to 3 letters, yes? But the biggest thing I would say with any of this here is keep referring back to the general forms. Because what is where? Do we have a value for HK or A? If we have a value for A, we're looking at what does A signify. If it's negative, it's a reflection across the x-axis. That's it. We're looking at those spots and seeing what does it tell me. If I have a value for H, it's telling me left or right. If I have a value for K, it's telling me up or down. It feels like there should be more than that, but that is really it. We look at those spots and see what it tells us. Now, there is a reflection across the y-axis, but it shows up inside the parentheses in front of H. If that spot's negative, that B value is negative, then there's a reflection across the y-axis. So, we're going to look at these two here. The graph p of x equals negative x squared and its parent function. So we want to determine what is the parent function for negative x squared. Anybody have a guess at what the parent function is? The Q, the quadratic. It is a quadratic, yes. You don't have to keep writing the general form each time. I write it just so we can see it. And if it does help to be able to compare the two, keep comparing them, keep referring back to them. As we look at this here, do I have a number in place of our k with being added on outside those absolute values or parentheses? No, there's nothing there, so there is no up or down. Do we have a value for h, or a number taking the place of h inside those parentheses? We don't have parentheses, so there is no movement to the left or to the right. There does not have to be a value in each spot. But we're going through and checking and making sure to see if there is. However, A is told to us to be negative, yes? If A is negative, there's a reflection across the x-axis. I see that it's negative, so there is a that's it. We're almost looking through or comparing it to the general form. Does it have a value in these spots? If it does, we list that transformation. If it doesn't, we're not. And really what we're doing is describing from the parent function to this one what happened. How did it change? What did we do to it to get here? We reflected across the x-axis. That's it. Questions on this here? We're kind of starting to see how it's just really, we're looking back at what's taking place and saying what it is. Are we ready for the next one? K of x equals negative x. What's the parent? Linear, absolute, quadratic. Linear. And you're right, for the most part, we won't be having too much inside those parentheses with linear by just describing it. There's no reason to leave them in, because if we did have them, we're going to multiply through by a, simplify as far as we can. There's no reason to leave them there. Quadratic, we leave them because that's actually, we have to distribute, we have to FOIL, we have to multiply all the way out. Vertex form is what that's called. We leave it in vertex form. What transformation do we have here? Do we have a value for H? Do we have a value for K? No, what do we have? We have this negative in place of A. If A is negative, it is a reflection across the x-axis. If B is negative, if we had it in front of that x inside the parentheses or absolute values, then it would be across the y-axis. Which, for some of these equations, it doesn't mean a whole lot. For linear, it just, instead of going up, it's going down. Questions on either one of these here? You know what? Let's look back at what we've done so far. We're going to do some more of up, down, left, right reflections. Number 2. G of x equals x plus 3. What would the parent function be? Linear, absolute value, quadratic. Linear. We don't have an x squared. We don't have a squared term. We don't have the absolute value. So yes, it is indeed linear. Let me try that again. Do we have a value for H? No. Do we have a value for A? I mean, no, technically, yes, it's 1, but 1's not changing anything. It's not negative, so there is no reflection. The only thing we have is K. What's the value of K? 3. K moves in what direction? Up or down? K is nice. Vertical translations are nice. It's going to be exactly what we think it is. Since it's plus 3, we're going up 3. So we say up 3. If it's linear, up 3. Questions on that there? We ready for the next one? What's the parent function for x minus 2 squared? It would be a quadratic. Do we have a value for k? So it's not moving up or down. Do we have a value for h? 2. Now we need to figure out, are we moving to the right or to the left? It would be to the right. I think this one's a little bit easier to see how this works, because the value of h tells us the direction we're moving. So if I compare it to the general form, x's match up perfectly, yes? The sign in the middle, the one we have here is negative. The general form is also negative, which means h has to be 2, positive 2. We don't take a sign with it. It's just 2. The x and minus already match the general form, so h has to be positive 2, which means we move right 2. That's kind of why it's the opposite of what we think. That minus in the middle throws it the other direction. Questions on the first two before we look at number 4? What's the parent function? Absolute. Absolute value. What is the one spot we have a sign or number? A. A is negative, yes. And since A is negative, it tells us we have a reflection across the x-axis. I will say this also, especially on the test, I'm not expecting you to memorize all this. Especially all the stuff we have down and how the letters connect. You can write that on the review sheet. You can use the review sheet on the test. Because again, a lot of this is just referring back to the general form. What is taking the place of what? Questions on any of this so far? Not too bad. Definitely need to try a few on your own just to make sure we got it down. We will have time for that. But vertical stretch and shrink. Vertical stretch and shrink. If A is greater than 1, it's a vertical stretch. If 0 is less than A is less than 1, it's a vertical shrink. Right added to that first page. If A is greater than 1, vertical stretch. If 0 is less than A is less than 1, it's a vertical shrink. So A has two things connected to it. The number, not the sign, but the number tells us if it's a stretch or shrink. As long as that number is not 1. If it's 1, there is no stretch or shrink. If it's different than 1, stretch if it's greater than 1, shrink if it's between 0 and 1. Now, technically, you do not need to add this, but technically, it is the absolute value of A. Because the reason we say absolute value is if it's negative, the negative does not impact it being a stretch or shrink. If A is negative, what? It's a reflection across the x-axis. If it's negative, it's a reflection across the x-axis. The number tells us stretch or shrink. Those are two separate transformations. Questions on this here? A, g of x equals 2 times the absolute value of x. What is the parent function? An absolute. Absolute value. We have no value for h. We have no value for k, so it's not moving up, down. It's not moving left or right. But A is what? 2? G? G of x, A is 2? Yes? You're good. 2? 2? Yes? Okay, just making sure. So, that's telling us one of two things, because A has a value, yes? Is that value negative? So is there no. So is there a reflection across the x-axis? No, there's no reflection, because if it had been negative 2, yes. Since it's positive 2, there is no reflection. So we've got to look at the other spot. Is a between 0 and 1 or greater than 1? Greater than 1. So it tells us that we have a what? Vertical what? Stretch, yes? Unfortunately, we can't leave it as just vertical stretch. We have to say how much. Vertical stretch of, what's 2? Yeah. Vertical stretch of 2. We just list whatever that value is. Now, if it had been, say, -2, we're not going to say a vertical stretch of -2. Because, again, the negative is associated with the reflection. Even when we talk about the vertical stretch, that negative is still part of the reflection. It's not about the stretch or shrink. Can we see how that kind of go together? And again, that's the reason it seems like I'm putting a lot of emphasis on this, because this is one of the spots where they get mismatched. Let's look at B. H of x equals 1/2 x squared. What is the parent function? Quadratic. We have that square. Still no h, still no k, so it's not moving up, down, left, or right. Here, a, we do have a value. It is 1/2, yes? Is it negative? No, since it's not negative, there is no reflection across the x-axis. So the only thing we have left to check is if it's vertical stretch or vertical shrink, because we do have a number there. It's vertical shrink, because it's vertical stretch if a is greater than 1. It's vertical shrink if it's between 0 and 1. And we'd say this is a vertical shrink of 1/2. Graphically speaking, when we say stretch, it's increasing along the y-axis faster, so it's getting narrower. Vertical shrink says it's being pulled out, it's stretched. We're compressing the y values, so it gets wider. Quadratic. And as we just said, for this here, 1/2 x squared, it got wider. The first one, 2x squared. Narrower. Questions on A or B? Let's look at number 5. G of x equals 3x. What is the parent? Linear. What would our transformation be? Yeah, so what's transformation? Transformation is all of this here. So transformation is any movement of vertical stretch or shrink, horizontal stretch or shrink. We haven't covered that yet. Vertical stretch of 3. Yeah, that's it. All of this is a transformation. Would we have a reflection across the x-axis? No, it's not negative, so there is not one. H of x equals 3/2 x squared. Parent would be quadratic. The main reason it's quadratic is that x squared, that squared term, telling us it's quadratic. Y equals a times x minus h squared plus k. We have no movement to the left or right. We have no movement up or down. But we do have a value for A, yes? It's positive, so we know there's no reflection across the x-axis, correct? It is a fraction, so it has to be a shrink, right? What is shrink? A has to be between 0 and 1. If it's greater than 1, it's a stretch. It's 3/2 between 0 and 1. If we're not sure, we can always, 3 divided by 2 is 1.5. It's greater than 1. So it's a vertical stretch of 3/2. I do that every year. I mainly do that because it's very tempting or very easy to see fractions. It's got to be shrink. We got to make sure that the fraction is not greater than 1. Greater than 1 is a stretch. Between 0 and 1 is a shrink. We'll look at one more for today. Number 7, C of x equals 0.2 times the absolute value of x. Absolute. Vertical shrink of 0.2. I know we have a few minutes to finish this.